Hello, my name is Matt Oswald, and this is a follow-up video of the Power of Test-Driven Network Automation presentation that I gave in a previous video, which should be linked there on the screen. So if you haven't seen that, please go back and watch that. That's a nice baseline for what we're going to be talking about today. In that video, I discussed the overview and high-level design of a new software project that I'm open sourcing called ToDD, which stands for Testing on Demand Distributed. And in this video, we're actually going to demonstrate ToDD. We're actually going to look at how to use ToDD and how to use it to run actual tests on our infrastructure. The topology that we're using for this demonstration is actually fairly simple. We have a total of 6 agents. These agents are reporting back to our ToDD server information about themselves, where they are, what kind of IP addresses are on the systems that they're installed on, things like that. What we want to do is we want to group 3 of these agents into a group called Data Center, and we want to group 3 more into a group called Headquarters. And we're going to be using these groups throughout the demo to execute our tests. Okay, so I've come over to the terminal. This is the screen that we're going to be using to demonstrate ToDD throughout this video. And first things first, let's just run ToDD to get a nice output of what's possible. This is the ToDD client. So as you can see, the ToDD client binary provides a very simple mechanism for interacting with the ToDD server, which happens to be located on the same server that I'm running the client on right now. We've got a few global options like the IP address and the TCP port of the server's API, but most of the real work is done using one of the subcommands that you see here. Let's first ask ToDD about the agents that are registered to it. As you can see, all 6 of our agents are listed here and are reporting information about themselves. And we can also see a summary of the facts that are being collected about each agent. Finally, the rightmost column tells us what fact collectors are installed on this system. Fact collectors are actually conceptually very, very similar to what you saw in the last video with respect to testlets. They are essentially self-contained executables. They could be Bash scripts, Python scripts, whatever language you wish to write them in. These particular ones are written in Bash, but their job is to just simply gather facts about the system that they're running on and report them back to the agent that's running them. Those agents then aggregate those facts upstream and send them to the server, so the server then can make decisions about those agents. Now, if we want to drill into the facts that are being gathered about one of these agents, all we have to do is just add the UUID to the end of that previous command. ToDD agents, and I'll just go ahead and copy and paste this one here. As you can see, we've got a little more detail here. We've got, again, the collector summary that we saw in the column. We've got the full UUID of this agent. And we also have a JSON dictionary containing the full fact set of what's being gathered. The 2 IP addresses that are on the system, naturally a loopback address, but then also the actual ETH0 address. We also have the host name of the system being gathered, which is ToDD-4. Now, these facts are actually what's used to group agents together. And you'll remember from the slide that I showed at the beginning of this video, our goal is to group 3 of these agents into our data center group and the other 3 into our headquarters group. So let's look into doing that now. The way that we group agents in ToDD is we upload something called a group definition. And I'm going to go into the docs/DSL directory. This is a directory inside of the ToDD repository that shows you some examples of these files that we're going to be defining. If we take a look at group.datacenter.yml, we see our group definition here. Now, the first 2 rows are pretty straightforward. We have a type, which is a group. This is the type of this object that we're creating. This YAML definition that we're creating is a group. And then also we're assigning a label to it. The label is called Data Center. We refer to this label when we want to do things like delete the object or refer to the object within ToDD. Then underneath the spec line here, you can see everything that actually defines this group. The name of the group is Data Center. So whenever agents get placed into this group, they're going to be known to be in group data center. And then everything under matches, these are match rules that define what it takes to get an agent into this group. Now, these particular match statements, ToDD can support matching on an IPv4 or an IPv6 subnet here, as you can see, within subnet 172.17.0.0/16, or on hostname. And it's not shown here, but you could also say hostname instead of within subnet. And then inside of the double quotes, you can either say the full host name that you want to match on. Obviously, that would only match one host name. Or you can also use a regular expression to potentially match more than one host name. Currently, those are the only 2 match statements supported by ToDD. I'm hoping that in the future we're going to have more options for matching, but right now it's limited to these 2. All right, so we have our YAML definition. In order to make this grouping object take effect, we actually can upload this to the ToD server like so. ToD create group datacenter.yml. Now we can query ToD immediately to see that this has been uploaded by saying ToD objects group. You can see that the label and the type, those two rows that we saw before, are here, and then the contents of the spec are also listed here. Now, every once in a while, ToD's going to look at all registered agents and make grouping decisions based on the group objects that have been uploaded. We can run the command ToD groups to see which agents have been placed in which groups. As you can see, it looks like 3 of our agents are accounted for, but the other 3 haven't, since we haven't added a group file that captures their subnet yet. No, so let's do that now. Let's take a look at group hq.yml. You can see it's much the same file. The contents are just a little bit different. The label and the group name are obviously also changed to headquarters instead of data center. And then naturally, since these agents operate on a different subnet, we have to change that as well. So as with before, ToD create group hq.yml, ToD objects group. You can see now we have 2 objects that have been uploaded to ToD. The second one, headquarters, is shown here underneath or alongside this second row. And then again, ToD groups will show us that now all 6 of our agents have a corresponding group name, and we are ready to proceed with the actual testing. Now, the act of giving ToD instructions about a particular test run is actually quite similar to how we just defined groups of agents. Now, ToD has a second agent type, a second object type known as a test run object, which is also defined in YAML. Now, you can sort of think of test run objects like integration tests for your network. You're really just describing what it is that you're running and how you want it to interact. That analogy is not perfect yet because we're currently not making any assertions on the data that comes out of the integration test, but that's certainly something I'm looking into doing. Now, here's one test run example where we've defined a simple ping test from our data center agents. If we look at test ping DNS, and I have really long file names for this for the time being. So you can see in this file we have a similar format to what you saw in the group definitions before. Again, every ToD object has a type and a label, and then underneath the spec is the information specific to that object type. Now, this particular test run has a field called target type, and it's set to uncontrolled. Now, if you remember from the slides presentation, which is the last video, you'll remember that there are 2 types of targets. The targets, uncontrolled targets, are just a list of IP addresses, really, or FQDNs, where you don't necessarily have a ToD agent running on those nodes. You're simply just targeting them, typically used for things like ping or some sort of a curl test if you want to just gather HTTP metrics on an existing HTTP server. Essentially, uncontrolled target type is, I'm not controlling these targets. They don't run ToD agents. I just want you to send traffic to them. So as a result of that, we have a single block for our source group. This source block defines how we want the agents that are in our source group to behave. Now, first off, we have to let ToD know what group we actually want to be the source. In this case, we want the source group to be our data center group. So in essence, this test run will be running from only our data center agents. Now, those agents are going to be running the ping app, and here ping doesn't necessarily mean the ping binary, as you probably are familiar. This actually refers to the testlet that's been installed on the system. So this is going to refer to the ping testlet, and the testlet is actually going to handle parsing all of the data from the output of ping and sending it back up to the ToD server from the standard out of the agent node. And then finally, args. This is what we actually pass into the testlet, and normally testlets really just honor this and send it along to the underlying utility, and that is true in this case. Specifically with the actual ping utility, -c space 10 means we want to send 10 ICMP pings. So we're really just specifying additional metadata for the actual underlying application to use. And then finally, the last block, target. This is real simple. This is just a list of IP addresses, right? So every single agent in the source group is going to run this testlet against each of these 2 targets simultaneously. Now, as with before, we can upload this object using the create command. And we can also see that the test run has been uploaded. The output is, I need to add a space here, but you can see the label is here. You can see the type of object that's been uploaded is a test run object, and then the spec here is shown to the right. Now, it's important also to note, again, that each object has a label. I mentioned when I was talking about the group definitions that these are used occasionally for running things within ToD. You actually refer to this label. And that's very true for when you actually want to run these test runs. We can actually use this label in conjunction with the ToD run command to instruct ToD to execute our test run. So we just simply say test ping DNS DC. That's the label of the object that we want to execute. And I'm also going to use an argument or flag -j. What this does is it says when you're done running the test run, I want you to output the JSON of the post-test metrics right to the screen here so that we can see it. Get some instant gratification that way. So I'm going to run this. And it's going to confirm for us, so we say yes. You could also use -y to skip this. Now, as mentioned earlier in the slides, what's happening here is that each agent in our data center group is being given a test instruction simultaneously. And each agent is running that test against every single target simultaneously. Now, you can see the progress of the test via the text shown after you run this command. As you can see here, we've got 3 agents in the testing phase, and it looks like they're wrapping up. They're very quickly moving into the finished phase. Very shortly, there we go, now we have a JSON document that shows us the metrics of each agent, and each agent, not only each agent, but also per target. The outside key here is the agent UUID. So this is the UUID of the agent that was running this particular test run. So there's 3 agents, and naturally there are 3 UUIDs. Now within each UUID, within each agent, there are also 2 targets, 4222 and 8888. And that's because each agent obviously is pinging each of these 2 targets. Now, inside of that are the 2 metrics that we are gathering, and this is totally up to the testlet. The ToD agent is not going to impose any sort of metrics on the test itself. These metrics are provided by the testlet. So if you wanted to extend this test and maybe gather some additional metrics that weren't being parsed out of the ping output, you certainly could do that by augmenting the testlet. And as you can see, we've got nice little average latency in milliseconds for both of these targets. And not only that, but we also see it from all 3 agents. So we got a nice little unique, diverse perspective of these 2 targets. Now, this kind of test run is really useful for running on a schedule or something like that. So you can see this data trending over time. However, that's not always what you're looking for. Sometimes you're trying to run an ad hoc test, perhaps during a period of troubleshooting. Now, while the test run YAML definition is optimal for these recurring tests, gathering data over time and trending it out, but during a period of troubleshooting, changing this field and re-uploading the objects, that can be a little bit of a pain. So in order to address that use case, we can actually override the source group with an argument to the ToD run command without messing with our grouping objects or our test run objects. Let's just say ToD run and then --help to see the arguments that are possible. You can see the J and the Y command flags that I specified earlier are here. We also have 3 others that I did not talk about. We can override the source group by using this particular flag here. What we're going to do is we're going to refer to the label of the existing object. We're going to say ToD run. We're still going to use the test ping DNS DC. Remember, this says I want to run the ping testlet from our data center agents. But instead of running it from the data center agents, I just want to override the group name. So it's going to keep everything else from that test run object, but it will override the source group. Meaning the same testlet and the same arguments for that testlet and the same targets, those are all going to stay in this particular test run. Those are still going to apply. It's still going to use those values from the test run object. But this particular value, the group, the ToD group that's being used as the source for this test, that will instead be headquarters. And we confirm. Now, it's worth mentioning, if you do choose to override one of these fields, ToD's going to recognize that you're probably doing a one-off test, and so it will just print the results to the screen. It's not going to do any integration with TSDBs or anything like that, because this might not be relevant to a maybe more consistent data set. This is sort of a one-off test. Nevertheless, it's still very useful for us to do to do some sort of point troubleshooting, and we can see now the same output just from a different perspective, different agent UUIDs because this is a different group. This is being used in the headquarters group instead of our data center group. Okay, so this is all great. We've been able to successfully run the ping testlet from not just one group but also two groups by using the override. But not all tests are as simple as just simply setting up some sort of simple utility to go ping something. Some tests are a little more complicated than that. Sometimes you need to set up the other end of the test instead of just the source group. A good example of this is the application iPerf, which has both a client and a server component. Now, I wrote a test run object to track the usable bandwidth between our data center and headquarters using iPerf. You can see this is kind of similar to the test run object that we saw before, but there is a big difference in that the target section is totally different. And it looks a lot like the source group. So let's step through this a little bit. Obviously, there's the type is test run. The label is unique. We want to make sure this has its own label. Underneath spec, you'll notice immediately that the target type is no longer uncontrolled. The target type is actually group. This instructs ToD, hey, we actually want to target a group of ToD agents and not just not only have agents at the source, but also at the target. So that means we still obviously want to specify the source group. We'll get to that in a second, but the target group also we are spinning up as well. And the anatomy here is exactly like you saw before in the source group. We're saying we want the name of the target group to be headquarters. So all of the agents in our headquarters group are going to be targets. The testlet that I want those agents to spin up is iPerf. And then the arguments that I want to send to iPerf is -s. The -s is a flag that instructs iPerf. This is an iPerf specific flag that says, I want to run you in server mode. So iPerf is going to spin up in server mode on all of our targets. Now, the source group is different also in the arguments that it's passing. You'll notice that I have this weird curly braces notation here. This is a way of doing some sort of target IP address substitution. So if, for instance, and iPerf is a great example of this because iPerf actually uses the target IP address in the arguments instead of the first argument, which is the testlet standard. And so by using this specification, anytime ToD sees these curly braces with the name target inside of args, it's going to replace that with the actual target IP address. And so when this test run gets placed down to the actual source agents, the source agents are going to know what IP addresses that it's testing against, and it's going to replace those in real time. And so if we just simply want to make sure that the target IP address is filled in, we just use this sort of notation. Now, when I run this, ToD is going to first start the test on the targets. You'll remember they run in a server mode, so we need to make sure those are started before we specify, before we instruct the clients or the source group to start their test. Now, when the targets are ready, they'll report back to the server, and the server is then going to execute the tests on the source agents. Again, this is very useful for apps like iPerf that require that the server is running before the client connections come in. As with before, we need to create the object within ToD, test DC. There we go. And we do ToD run, test DC HQ bandwidth, -j to output the nice JSON document for us. Now, as you can see, we've got 6 agents engaging in the test, and now it's going to go down to 3 out of 6. And then you can see it goes down to 1 out of 6, and now they're going to go 6 out of 6 finished. The reason it stutter stepped like that was actually because we wanted to make sure that the targets were set up first. And so ToD was actually stepping through, making sure that all the targets were running, and then once it verifies that they were all running, it's going to create an execute test order on all the source agents so that they can run their throughput testing. As you can see, we've got similar metrics to what we saw before. We've got 3 agents in our source group, so we have 3 sets of data. But you can see now we also have 3 targets. Those 3 targets are the IP addresses of our actual target agents. And that's why we have 3 this time, because there are 3 agents in that target group. As I mentioned before, the metrics gathered are totally up to the testlet, so we've defined those here. You can see bandwidth in megabits per second. We have 743 transferred. We also have the total transferred in megabytes, which is 886. And then finally, the TCP window size in megabytes is 0.04. So that is a summary of the findings for that particular test run. Now, these are just two examples of tests that you can run. This format is compatible with just about any testlet that you can write. For instance, I've not yet written testlets for like a web server HTTP example, but once I do, I could use a testlet that looks a lot like this. Right? It's the exact same thing as we saw before, and we can use different testlets because the source group uses a different application to create a request, an HTTP request, as the target does to serve those HTTP requests. This is obviously something that has a lot of tremendous value for SaaS providers, application developers, web application developers, because they can actually spin up instances of their web apps here within ToD and then test against them all in one fell swoop. Okay, I mentioned before that we are actually trending this data over time. So I want to show how that's being done. The initial integration is with InfluxDB. This is a very popular time series database. If we want to run, we can actually check on the metrics for a specific test run object by saying select all from / test run test DC HQ bandwidth. And this is the specific series for our iPerf tests. You can see that we have timestamps here, the agent UUID that gathered the metric, the bandwidth in megabits per second, the source group. So we're not only publishing values, we're also publishing some useful metadata about the test. Where did this test originate from a group perspective? What target is this particular value relevant to? And here's another value, TCP window size in megabyte. We have the test UUID. The test that's executed also has a UUID generated for it. This is the way that we can keep these metrics a little bit more isolated from each other. And then finally, the final value, transfer _ megabytes. Now, one of the really cool things that we can do now that we have that data in InfluxDB is actually visualize that data using a tool like Grafana. As you can see, we've got two graphs here. The first one is latency to DNS providers from data center. So this corresponds to that test run object that we saw before where we were using our data center group of agents to ping 8888 and 4222. You can see that in green we have the ping results to 4222 from this group, and I believe this is an average, right? So this is an average of the latency that's been gathered from all agents in that group. It's being placed here. It looks like it's averaging about 20 milliseconds, occasionally a very small spike, but it's pretty much staying static there. Also the yellow is to 8888, much lower latency, and pretty consistent as well. Now, where things get really, really interesting is the second graph, bandwidth between HQ and data center. So you can see here that we are splitting this graph into different targets. We could just as easily aggregate these, maybe average them out, but I chose to break them out individually just in case there was a significant impact to bandwidth on one of these agents. Now, another thing that we could do is this graph doesn't actually correspond to a single target. We could actually have two test runs running, alternate them together, maybe bandwidth between HQ and data center, and then maybe another one being bandwidth between data center and branch office 1, for instance. Now, those are two different test runs from a ToD perspective, but because ToD is writing the appropriate tags into InfluxDB, we could actually put both of those test runs onto one graph. Right, so Grafana gives us the tools that we need to do that based off of the metadata that's provided by ToD. So there's so much to play with here. This is certainly not the only way to graph this data out. I put this here as a demonstration. The data that my goal with ToD was to write as much useful metadata into InfluxDB as possible to sort of give visualization tools the leeway to do sort of whatever they wanted to do. I want to thank you again for watching. As you can see on the screen, my contact info is there. Hit me up on my blog at keepingitclassless.net or on Twitter as Meerden. And then you can find ToD specifically at github.com/Meerden/ToD. Anything to do with documentation. If you want to open up an issue or maybe browse the existing issues that have been opened, feel free to peruse those. I do accept pull requests. Please look at contributing.md for the guidelines on how to do that. But other than that, I'd love to hear from you. Any feedback, whether it's formal, informal, maybe something that you'd like improved or added to ToD, feel free to hit me up on any of those mediums and we'll have a conversation. Thanks so much for watching. Have a great day.